good afternoon everyone. Just quickly confirm audio video is clear. Kindly confirm audio video is clear to everyone. Just quickly confirm whether audio video is clear. Just confirm me once audio video is clear and then we'll start. So a very good afternoon everyone. Myself Prateek Mishra and I welcome you all to the YouTube platform of IMS GATE Academy. We are conducting the foundation series just to make your foundation strong so that you can have the best of the rank in upcoming GATE 25 examination. This series is especially designed for those students who have just started with their preparation. This series is also for those students who lacked some basics while they were preparing earlier for GATE 24 examination. So whatever sessions we have conducted previous two sessions. First one was on water demand, second one was on physical water quality parameter that was conducted yesterday. A very good afternoon Matan, very good afternoon Gagan. Okay, today's session will be an important session. Reason is, in this session you will get to know about the basics from where regular questions are asked. If you expect any question from water quality parameter, there are more than 90% chances that it will be framed from today's session, especially whatever basics that we will going to discuss. So kindly stay tuned till the session gets over. We will going to see some of the basics that you might have read already, but still we will going to brush up all these concepts. Okay, my dear students, environmental engineering is a fusion of technical learning plus the basics of chemistry that you read in 11th or 12th class. So today we will going to see some of those basics as well, and we will going to see those basics in very simple and understandable way, right? So this is our session for chemical water quality parameter. Before starting this session, few announcements I need to make. Telegram group link is given in the description box. Kindly join our Telegram group for enjoying the daily quizzes, for getting the YouTube session updates, for getting the lecture PDFs of YouTube, for getting the notification of PSU jobs and other government jobs. We at IMS GATE Academy, my dear students, we offer you 4 different types of courses where we provide 800 hours of live teaching with interaction. We provide you with the theory and exercise book, and especially our exercise book containing more than 4,000 practice questions well versed in level 1, level 2 and level 3, so that even you can analyze what is your preparation level. We provide you with the GATE question bank, exclusive GATE question bank, one of the premium product of IMS GATE Academy, where more than 34 years of GATE questions are there. Means since the time GATE started, we have included all the questions. They are well placed in different chapters and at different sections. We provide you with detailed solution, alternate solution, video solution along with the chapter overview and the key points, which is a game-changing thing in your entire preparation journey. We at IMS GATE Academy is the only institute providing personal guidance to our student by providing 12 personalized one-to-one mentoring sessions. Along with that, we provide you with India's largest test series containing more than 130 plus tests, starting from chapter test, subject test, multiple subject test, advanced subject test, then the full-length mock test, along with the video solution. Right now, we are running offline centers at Bangalore and Vijayawada, and if you are anywhere in India, you can join our online program. And especially for the students who are staying nearby Bangalore or Vijayawada, they can take up also the hybrid program, which is a fusion of online and offline learning. So with this announcement, I would like to begin my today's session, my dear students. As yesterday we have seen, the quality of water can be analyzed using water quality parameters. There are basically 3 water quality parameters: physical water quality parameter, chemical water quality parameter and biological water quality parameter. Yesterday only I have told you that all the water quality parameter that can be felt and sensed by any of our senses are classified as physical water quality parameter. Now coming to the second one, chemical water quality parameter. These water quality parameter actually affects the chemical property of water. The list of chemical water quality parameter goes with dissolved solids, alkalinity, pH and hardness. These are the very, very important chemical water quality parameter. Then other chemical water quality parameter includes chloride content, fluoride content, nitrogen content, dissolved gases like H2S, CO2, oxygen, all those things. And then you have metals, which includes copper, iron, magnesium, all those things. But if I talk about the important areas where we are seeing regular question is these three chemical water quality parameter. Alkalinity, pH and hardness. Very good quality question can be framed from these three areas. Now what happens is, when any student sees the question from this segment, he actually leaves it. Reason is, all the questions which are framed from this segment requires the use of basic chemistry that you learnt in your school. And due to not revising those concepts, again we forget all these concepts, or either we are too much confused in these concepts. So this is one of the main area from where question can be framed, good quality question, right? So in order to deal with the question framed from this area, you should have the basics of chemistry. So I'll start with this. I'll start with some of the basics of chemistry that is required. So first of all, my dear students, can you tell me what do you mean by Avogadro's number? Can anybody tell me in the comment box what do you mean by Avogadro's number and why it is used? What is the reason of using this number and where we are using this number? Can anybody tell me? You might have learned this in your school, especially from 9th class onwards. In the 9th class, we read this for the first time, and since then, we have all these basic doubts in chemistry, right? Can anybody tell me where we read this Avogadro's number? And what is the purpose of using this number? Chalo, I'll start with this. For example, since we are conducting this classroom teaching, so I'll give you an example from classroom teaching, right? Suppose this is your class and you are here somewhere in your 9th class, right? If a teacher asks you how many students are sitting in the class, then what you used to do? You used to simply count the number of heads like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like this. You can count and you can tell ki ma'am, these many students are sitting in the class. Okay. But on the other hand, if I ask you that how many atoms are present inside this box, means in this space, how many atoms are present? Then you will tell me a number which is like millions and billions and millions. Like it's a huge number that will come up because all these quantities are very, very small. And in very limited space, there can be millions, billions and millions of molecules and atoms present. Okay. The scientific way of telling the number of atoms or number of molecules present in a space is by using this Avogadro's number. There are two ways of telling the number of molecules, atoms and electrons present in any space. What you can do is, you can literally count and you can write down one number like this, right? And it will come out to be a huge number, which is not at all convenient to analyze, not at all convenient to understand, okay? Then what Avogadro did it, he has given one number which is 6.022 into 10 raised power 23. This is Avogadro's number. Okay. So, this is your Avogadro's number. Now, what you did is, you just counted the number of atoms that are present. Say you come out some X value. Okay. You come out with some X value. X is the number of atoms that are present in this space. What is X? It is the number of atoms, or I should write down number of entities. Entities will include atoms, molecules, or electron. This is totally of your choice. Molecules, electrons, protons, any entity of your choice. Means, if I ask you, how many entities are present in this space? So you have literally counted all the entities and you said me ki sir, X is the amount of entities which are present. Now this X is very huge. Okay. So what Avogadro did is, whatever X you got, he divided this X with 6.022 into 10 raised power 23. This ratio will tell you the number of moles. This ratio will going to tell you the number of moles of entity. This ratio will going to tell you the number of moles of entity, right? This ratio will going to tell you the number of moles of entity. That's why all the electrons, protons, atoms, molecules are represented in terms of moles, okay? Mole is just a number, right? Number of moles actually tells you how many entities are present in any space. How to calculate the number of moles? You have literally calculated the number of quantities or number of entities, and you have simply divided it with the Avogadro's number, which is 6.022 into 10 raised power 23. That will going to give you the number of moles. And this number of mole is very easy to understand. It is very easy to analyze the number of moles of entity, right? If I tell you, just imagine, you take this number 6.022 into 10 raised power 23 and you multiply it by 5, right? Again, a huge number will come out, and that huge number is very difficult to analyze. But on the other hand, if I simply say that 5 moles of entities are present, then in back of your mind, you can clearly identify that, okay, 5 into this much quantity of entities are present. Or simply you can just analyze, okay, 5 mole of atoms or 5 moles of molecules are present in certain space. So that is how this Avogadro's number came into picture, and this Avogadro's number has given one concept which is known as the mole concept. How we determine the number of moles? It's simple. For determining the number of moles, you have simply counted the number of quantities or entities and you have divided it by Avogadro's number. 6.022 into 10 raised power 23 number of entities is termed as 1 mole of the entity. Please remember this. 6.022 into 10 raised power 23 number of entities are termed as or are simply 1 mole of entity. Is simply 1 mole of entity. Now you will ask me, sir, this entity can be electron, proton, neutron, atoms, molecules, anything which you are analyzing. This entity can be either atoms or molecules or electrons or neutrons or protons, right? It can be anything that you are analyzing. So 1 mole of anything means 6.022 into 10 raised power 23 number of that entity. Simple. So what is a mole? Mole is just a number, right? Mole is a number to represent very small quantities or very small entities. These small entities include atoms, molecules, electrons, protons, etc. All those things, right? So this is simple. Avogadro's number is, I think, clear to you. You are clear that why we are using Avogadro's number? So Avogadro's number is basically used to calculate the number of moles. Okay, so this is just one way of calculating the number of moles. Now, chalo, I'll continue from here. So first of all, what do you understand by the atomic weight? Can anybody tell me? I don't want the definition that you read in your chemistry classes, right? All of you have those definitions, and due to those definitions, you have so many confusing points. In simple words, can anybody tell me what do you mean by atomic weight? As you can see here, atomic weight, weight of an atom, weight of 1 mole of atom is termed as the atomic weight. Again, I am repeating, don't go with the basics or don't go with the definitions of chemistry, right? It was okay at that level, but for this level, you need to upgrade. You need to read in such a way that you can actually solve the question. And for solving the question, this approach is important. So what is atomic weight? Weight of 1 mole of atom is termed as the atomic weight. Weight of, what is atomic weight? It is the weight of 1 mole of atom. Weight of 1 mole of atom is termed as the atomic weight, right? Just for you, the atomic weight of carbon is 12 gram. Have you ever thought why it is 12 grams? Grams, right? Gram is a very large weight. So weight of 1 mole of carbon atom is 12 grams. Similarly, atomic weight of oxygen is 16 gram. It means that weight of 1 mole of oxygen atom is 16 gram. Similarly, weight of 1 mole of hydrogen atom is 1 gram. Similarly, weight of 1 mole of nitrogen atom is 14 gram. Like this, you define the atomic weight. Atomic weight is simply the weight of 1 mole of any atom. That is the atomic weight, right? Again, I am repeating this. Don't go with all those definitions that you have read. It is fine. If you want to read it, you can again go back to 9th class and read it. But for solving the questions of environment, you need to have certain basics like this. So atomic weight is simply the weight of 1 mole of atom. So 1 mole of carbon will going to weigh 12 gram, 1 mole of oxygen will going to weigh 16 gram, 1 mole of hydrogen will weigh 1 gram and 1 mole of nitrogen will weigh 14 gram. Similarly, you can identify what is the molecular weight. Weight of 1 mole of any molecule is termed as molecular weight. So what is molecular weight? Weight of 1 mole of any molecule is termed as the molecular weight. So molecular weight is nothing but weight of 1 mole of any molecule. 1 mole of any molecule. 1 mole of any molecule is termed as its molecular weight. Weight of 1 mole of molecule is termed as its molecular weight, right? 1 mole of weight of 1 mole of molecule is termed as molecular weight. That is why if I ask you what is the molecular weight of hydrogen H2O, so what you will do is you will simply take 2 into 1 gram. 2 into 1 gram plus 16 grams. Oxygen is 16, hydrogen is 2. So 2 into 1 plus 16, that is your 18 gram. Now what is this 18 gram? 18 gram is the molecular weight of H2O. That is 1 mole of H2O will going to weigh 18 gram. Okay. Similarly, you have this CaCO3. CaCO3 is 1 molecule. Then Ca, calcium is 40 gram. Calcium is 40 gram. Then carbon is 12 gram. Then oxygen you have 3 atoms. So plus 3 into 16 gram. Okay. So this will come out how much? This is 48. 48 plus 12 is 60. 60 plus 40 is 100. So this is your 100 gram. This 100 gram is weight of 1 mole of CaCO3. So molecular weight is simple. What is molecular weight? Molecular weight is weight of 1 mole of any molecule or weight of 1 mole of that molecule. Okay, now you can very easily relate how to calculate the number of moles. For example, if I ask you how many moles of CaCO3 are present, how many moles of CaCO3 are present in 230 gram of CaCO3? In 230 gram of CaCO3. It is very simple. Question is simple. Question is asking you how many moles of CaCO3 are present in 230 grams of CaCO3. So this time 230 gram is the weight given to you and you are asked to calculate the number of moles. How to solve this? So I will write down given weight of CaCO3 is given weight of CaCO3 is, given weight of CaCO3 is 230 gram, okay. You know that weight of 1 mole of CaCO3, this is equal to calcium is 40 gram, again carbon is 12 gram, then oxygen is 16 grams. So 3 into 16 grams. So this will come out as 100 gram, right? So you know the weight of 1 mole of CaCO3. You know the given weight of CaCO3. You can calculate the number of moles. Number of moles of CaCO3, number of moles of CaCO3 is equal to the given weight divided by the molecular weight. Given weight of CaCO3 divided by the molecular weight of CaCO3. So given weight of CaCO3 is 230 gram. Please take care of the units, right? Molecular weight will always be in gram. Similarly, atomic weight will always be in gram. So 230 gram divided by 100 gram. So this will come out as 2.3 moles. So 230 gram of CaCO3 will contain 2.3 moles of CaCO3. I think this basic is clear to you. This basic is clear to you. Tell me yes or no. Is it clear to you or not? Is this clear? So this is how you calculate the number of moles. If you want to have the formula for number of moles, so this is the formula that you have. Again, I'll write down number of moles is equal to given weight divided by the molecular weight. Usually we deal in molecules, that is why I am writing the molecular weight. If I ask you the number of moles of any atom, so instead of molecular weight, you will going to add the atomic weight. Simple. Number of moles is equal to the given weight divided by the molecular weight. So this is an important formula, right? Please take care of this formula. Number of moles is equal to the given weight divided by the molecular weight, right? So this is clear to you. First thing is Avogadro's number. Second is how to calculate number of moles. So till now we have seen two ways of calculating the number of moles. The first way is counting all the molecule, atom, electron, means counting all the entities, then divided by the Avogadro's number, that will be the number of moles. The second way of calculating the number of moles is given weight of the entity divided by the molecular weight, or given weight of the molecule divided by the molecular weight, right? Now next comes is molarity. Till date, most of the student has confusion in this. What is molarity? Okay. In simple words, for example, if you take any salt and you mix it in water, that salt will going to dissolve. Now this salt that you have dissolved in water is termed as solute, and the matter in which this salt is getting dissolved is termed as solvent. Okay. This is your water, right? This is your water. This is your water in which you are putting in the salt. This is the water in which you are putting in the salt. So this water is termed as solvent. This water is termed as the solvent, and this salt is termed as the solute. This salt is termed as the solute, means the fluid in which anything is getting dissolved is termed as the solvent, and the thing which is getting dissolved is termed as the solute. Similarly, you can add any chemical to the other chemical. For example, I'll make it general like this. Say this is chemical 1. This is chemical 1, right? So this is chemical 1, in which you are adding chemical 2. In chemical 1, you are adding chemical 2 and you want to dissolve this chemical 2 in chemical 1. The chemical in which chemical 2 is getting dissolved is termed as solvent. This is termed as solvent, right? And the chemical which is getting dissolved is termed as solute. So this chemical 2 is termed as solute, okay? Now, what do we mean by molarity? Very, very easy to understand. I have given you one basic idea about how the things go in environmental chemistry and from where you can expect a question, right? So, what is the process which is taking place? You are adding chemical 2 in chemical 1 and this chemical 2 is getting dissolved in this chemical 1, right? The number of moles of chemical 2 getting dissolved in 1 liter of chemical 1 is termed as the molarity of this solution. This is the solution that you have prepared. This is the solution that you have prepared. So what is molarity? Number of moles of chemical 2 getting dissolved in 1 liter of chemical 1. Number of moles of chemical 2, number of moles of chemical 2 getting dissolved in 1 liter of chemical 1. 1 liter of chemical 1 is termed as molarity of the solution. Is termed as molarity of the solution. Is termed as molarity of the solution. In very, very simple words, I have told you how to understand the molarity. Molarity is simply how many number of moles of chemical 2 are getting dissolved in 1 liter of chemical 1. Now, usually in environmental engineering, this chemical 1 will be water and this chemical 2 can be other things, right? It varies from case to case. Chemical 1 necessarily will be water. This chemical 1 will always be water. Always, always. In environment, this chemical 1 will always be the water. So, if I want to define the molarity of the solution, it is simply the number of moles of anything dissolved in 1 liter of the solution or 1 liter of water is termed as the molarity of the solution. Number of moles of chemical 2 getting dissolved in 1 liter of water or chemical 1 is termed as molarity of the solution. So please remember this. Please remember number of moles of chemical 2 and remember 1 liter of chemical 1, that is water. That will going to help you to define the molarity of the solution. Okay. Now for example, if I ask you, what is the molarity of the solution? What is the molarity of the solution? What is the molarity of the solution? Molarity of the solution. What is the molarity of the solution containing in which in which 380 milligram of CaCO3 is dissolved is dissolved in 2 liters of water. 380 milligram of CaCO3 is dissolved in 2 liters of water. Can you tell me what will be the molarity of the solution in which 380 milligram, sorry not gram, 380 milligram of CaCO3 is dissolved in 2 liters of water. Okay. So how to calculate the molarity? First step is you calculate the number of moles of CaCO3. So first step is calculate the number of moles of CaCO3. So number of moles of CaCO3 is equal to the given weight of CaCO3. Please take care of the units. The given weight of CaCO3 is 380 milligram. 380 milligram. So this is 380 milligram. 380 milligram divided by the molecular weight of CaCO3. Previously we have just calculated the molecular weight of CaCO3, which is 100 grams. So the molecular weight of CaCO3 is 100 grams. Now in the examination usually these kind of mistake happens. We don't take care whether which one is gram, milligram, like that it happens. Now you convert this milligram to gram, then only this gram and gram will cancel out. So you will be having 380 into 10 raised power minus 3 divided by 100. Now these are the number of moles of CaCO3 that are present in 380 milligram of CaCO3. So you can calculate from here. It will be 380 into 10 raised power minus 5. 380 10 raised power minus 5 is the number of moles of CaCO3 that are present in 2 liters of water. 380 milligram of CaCO3 is dissolved in 2 liters of water. So these many moles of CaCO3 are dissolved in 2 liters of water. So from here only you can calculate how many moles of CaCO3 are dissolved in 1 liter of water, and that will be the molarity of the solution. So molarity of the solution will be, I'll write here. Meanwhile, you can just calculate the molarity and you can comment in the chat box. Meanwhile, you just calculate the molarity and comment in the chat box quickly. Chalo. So molarity of the solution will be, molarity of the solution will be number of moles of solute. And what is a solute? Solute is CaCO3. And this CaCO3 is getting dissolved in water. Number of moles of solute divided by the volume of solvent. Right? Number of moles of solute is 380 into 10 raised power minus 5. 380 into 10 raised power minus 5 divided by the volume of the solvent, that is 2 liters. So 380 moles of CaCO3 are dissolved in 2 liter of water. So in 1 liter of water it will be how much? This will be 1, this is 10 raised power minus 5. So 190. So this will be 190 into 10 raised power minus 5. This will be the molarity, or you can write down this as 0.0019 molar. So this solution is 0.0019 molar solution of CaCO3. So whenever these kind of terms are there, now you cannot panic, right? You know the basic how to deal with these kind of terms. Whenever any M or N was written after any number, then usually we used to have so many confusion. But I think this is clear now, how to calculate the molarity of the solution, what we actually mean by molarity of the solution. So molarity is simple, the number of moles of solute dissolved in 1 liter of solvent. Simple. Whenever you are asked to calculate the molarity, first you can calculate the number of moles of the solute that we have calculated. CaCO3 is the solute that we have. And then for calculating the molarity, you simply divide these number of moles with the volume of solvent. So here the volume of solvent is 2 liters, right? So molarity is reported as 0.0019 molar. This is our molarity, right? So this is how things goes with the basic chemistry. So you studied, you have read atomic weight, you understood molecular weight, then you know how to calculate the number of moles. Now after number of moles, you have defined the molarity. And I think all these 4 things are very much clear to you. Moving on to the next basic term, that is known as the valency. Now again, when we read this valency in our school, we have so many confusion. In simple words, for us, this is a benefit, right? Especially if any question comes in environmental engineering, this is the benefit for us. For example, if you write down sodium plus, here the valency of sodium is 1. Here the valency of sodium is 1. Very simple. I am not telling you any definition. I am just telling you how to identify the valency. As simple as that, right? Then you have calcium, Ca2 plus. It is, the valency of calcium will be 2. Similarly, if you have iron 3 plus, then the valency of iron will be 3. If you have molecule like HCl minus, right, here the valency will be 1. Like that. So either for us, valency will be 1 or the valency will be 2. In rare cases where iron, aluminium, all these compounds will be present, there the valency will be 3. Okay. If this kind of things come, CaCO3, right, then how to identify the valency? So this CaCO3 is formed when calcium 2 plus ion is combined with CO3 2 minus ion. Okay. Now from here I can tell you some part of the definition of valency. Actually valency is a very descriptive topic, right? So instead of going into the details, just know this fact that valency is the number of electrons for which a reaction has taken place, or the number of electron exchange for which the reaction has taken place. So valency is simply the number of electrons for which the reaction has taken place, the number of electron exchange for which the reaction has taken place. Here you can see for 2 electron, this reaction has taken place. Therefore, valency of CaCO3 will be equal to 2. Here the valency of CaCO3 will be equal to 2 because this reaction has taken place for exchange of 2 electron. Reaction has taken place for exchange of 2 electrons. For exchange of 2 electrons. For exchange of 2 electrons, right? So valency simply means for how many electron exchange a particular reaction is taking place. For us, it will be simple. Either it will be 1 or it will be 2. In extreme cases like iron, aluminium, it can be 3. Okay. But most of the cases you have this either 1 or 2. Now next is, what do we mean by the equivalent weight? Equivalent weight is weight of one valent ion or weight of one valency of entity. So equivalent weight is weight of one valency of entity. So if you do not understand this, equivalent weight is simple molecular weight divided by the valency. So what is the equivalent weight? Equivalent weight is, this equivalent weight is molecular weight divided by the valency. Equivalent weight is molecular weight divided by the valency. Simple. So what is equivalent weight? Equivalent weight is the weight of one valency of the entity, or one valent of the entity. Weight of one valent of the entity is termed as the equivalent weight. Okay. So equivalent weight is molecular weight divided by the valency. For example, if you need to calculate the equivalent weight of CaCO3, why I am taking CaCO3? Because it has a reason. So observe this. So I want to calculate what is the equivalent weight of CaCO3. So equivalent weight of CaCO3 is equal to molecular weight of CaCO3. It is equal to the molecular weight of CaCO3, molecular weight of CaCO3 divided by the valency of CaCO3 divided by the valency of CaCO3 divided by the valency of CaCO3. Can you tell me what is the molecular weight of CaCO3 quickly? Can anybody tell me what is the molecular weight of CaCO3? What is the molecular weight of CaCO3? So molecular weight of CaCO3 we have already calculated. Again, if you want, so calcium is 40 gram, carbon is 12 gram, then oxygen, 3 atoms are there, so 3 into 16 gram. This is the molecular weight of CaCO3, and valency of CaCO3 is equal to 2, that I have just explained you, right? So this will going to give me the equivalent weight of CaCO3. So molecular weight of CaCO3 is 100 grams divided by the valency of CaCO3 will be 2. So the equivalent weight of CaCO3 will be equal to 50 grams, like this, right? Similarly, you can calculate the equivalent weight of atoms also. So equivalent weight of atoms, equivalent weight of atoms is equal to atomic weight of atom is equal to atomic weight of atoms divided by the valency of atom, divided by the valency of atom, valency of atom, divided by the valency of atom, right? Atomic weight of atom divided by the valency of atom, okay? For example, you need to calculate the equivalent weight of calcium. You need to calculate the equivalent weight of calcium. You need to calculate the equivalent weight of calcium, right? So the atomic weight of calcium is 40 and the valency of calcium is 2. So atomic weight of calcium divided by the valency of calcium, divided by the valency of calcium, right? So atomic weight of calcium is 40, valency of calcium is 2. So the equivalent weight of calcium will be come out as 20, and this will be 20 grams. This will be 20 grams. So this is the equivalent weight of calcium. So for any molecule or any atom, you can calculate the equivalent weight. So equivalent weight is simply the molecular weight of molecule divided by its equivalent weight, okay? Now from here, we can also calculate the next quantity, that is number of gram equivalents. Just like number of moles, another quantity is number of gram equivalents. Just like number of moles, you have next quantity which is known as number of gram equivalent. Number of gram equivalent is defined as the ratio of given weight of the entity divided by its equivalent weight. So number of gram equivalent is equal to the ratio of given weight given weight divided by the equivalent weight. Given weight divided by the equivalent weight. Given weight divided by the equivalent weight, right? Number of gram equivalents is equal to given weight divided by the equivalent weight. Let's take one example. If I ask you how many number of gram equivalents are present, how many number of gram equivalents of CaCO3 are present in 420 gram of CaCO3. How many number of gram equivalent are present in 420 gram of CaCO3? So how you will calculate? You will simply apply this formula. It is the given weight divided by the equivalent weight. So number of gram equivalents of CaCO3 is equal to number of gram equivalents of CaCO3 is equal to given weight of CaCO3 divided by the equivalent weight of CaCO3 divided by the equivalent weight of CaCO3. So this is how you can calculate the number of gram equivalents of CaCO3. Number of gram equivalents of CaCO3 is simply equal to the given weight of CaCO3 divided by the equivalent weight of CaCO3. So number of gram equivalents of CaCO3 is equal to given weight is 420 grams. Again, please keep a check on the units. Given weight is 420 gram and equivalent weight of CaCO3 is the molecular weight of CaCO3, that is 100 gram, divided by the valency of CaCO3, which is 2. So this will be 100 by 2. So this comes out as 420 by 50. You can keep a check. I am always writing down the units, so I don't have any confusion while solving these questions. In these type of question, usually if you apply the concept, again you need to keep a strict check on the units because there is huge possibility that you will going to commit mistake here. Okay. So this will be how much? So this is 0 and 0 will cancel out. This will be 8.4 number of gram equivalents. So number of gram equivalents of CaCO3 that are present in 420 grams of CaCO3 will be 8.4. These many number of gram equivalents will be present. Okay. These many number of gram equivalents will be present. Now, using these number of gram equivalents, we came up with one more concept and that is known as normality. Okay. The next concept that we have is normality. Next concept is normality. Now, what is normality? Again, solute is getting dissolved in solution. Solute is getting dissolved in solution. Again, chemical 1 is getting dissolved in chemical 2. Chemical 2 is getting dissolved in chemical 1. Again, this chemical 2. This is my chemical 2. Again, this chemical 2. This is chemical 2. Again, this chemical 2 is getting dissolved in chemical 1. Again, this chemical 2 is getting dissolved in chemical 1. So, chemical 1 will be my solvent and usually this solvent for us will be water. And chemical 1 is termed as solute. Okay. And when this chemical 2 gets dissolved in chemical 1, it will going to form a solution. So, again we have defined normality in terms of number of gram equivalents. So, how do we define normality? Normality is number of gram equivalents of solute dissolved in 1 liter of solution. Simple. Normality of solution is number of gram equivalents of solute, that is chemical 2, getting dissolved in 1 liter of solvent. Normality is defined as, it is the number of gram equivalents, it is the number of gram equivalents of chemical 2, that is solute. Number of gram equivalents of chemical 2, that is solute, dissolved in 1 liter of solvent. Dissolved in 1 liter of solvent. So, number of gram equivalents of chemical 2, that is solute, dissolved in 1 liter of solvent is defined as the normality. Okay, so I think it is very much relatable. For the molarity, we have simply calculated the number of moles of solute dissolved in 1 liter of solution. For normality, we have to simply calculate the number of gram equivalents of solute dissolved in 1 liter of solution. So like this, you can calculate the normality of any solution. So if I ask you, find the normality of the solution, find the normality of the solution, question is, find the normality of the solution, find the normality of the solution, find the normality of the solution in which 500 milligrams of CaCO3 is dissolved in 5 liters of solution or 5 liters of water. Is dissolved in 5 liters of water. So you need to find out the normality of this solution in which 500 milligram of CaCO3 is dissolved in 5 liters of water. So water is a solvent. So step number 1 is you calculate the number of gram equivalents of CaCO3 that are present in 500 milligram of CaCO3. So number of gram equivalents of CaCO3 is number of gram equivalents of CaCO3. So number of gram equivalents of CaCO3 is given weight of CaCO3. Again, please keep a check on the unit. So 500 into 10 raised power minus 3 gram. This is milligram. Converting this milligram into gram will be 10 raised power minus 3 divided by the equivalent weight of CaCO3. So equivalent weight of CaCO3 is molecular weight of CaCO3, that is 100 gram, divided by the valency of CaCO3, which is 2. So this will be the equivalent weight of CaCO3, that is 50. And this entire quantity will going to give me number of gram equivalents of CaCO3. So the number of gram equivalents of CaCO3 will come out how much? This will be equal to 500 into 10 raised power minus 3 divided by 50. So this will be how much? This will be like 10 times. So 10 into 10 raised power minus 3. So this will be 0.01 normal solution. This is 0.01 normal solution. So like this, you can calculate the normality of any solution, right? So these basics are like very, very important with respect of solving the gate question especially. So normality is defined as the number of gram equivalents of solute dissolved per liter of solvent. Normality is defined as number of gram equivalents of solute dissolved in per liter of solvent. Okay, so like this you can calculate the normality of the solution. Chalo, moving ahead. Now these two are the facts that we use basically. Right now you just remember these two facts simply. Fact number 1 is 1 gram equivalent of anything is equal to 1 gram equivalent of any other thing. Means weight of 1 gram, sorry, weight is almost same. So 1 gram equivalent of anything is equal to the 1 gram equivalent of any other thing. Similarly, the second fact is 1 gram equivalent of anything reacts with 1 gram equivalent of any other thing. 1 gram equivalent of any other thing means if there are two entities like A and B and both of them are reacting. So 1 gram equivalent of A, 1 gram equivalent of A will react with only 1 gram equivalent of B. 1 gram equivalent of A will only react with 1 gram equivalent of B to form product C. So 1 gram equivalent of C will be formed. 1 gram equivalent of C will be formed. Means if I know the number of gram equivalents of A, if X is the number of gram equivalents of A, if X is the number of gram equivalents of A, then I also know the number of gram equivalents of B. Because X number of gram equivalents of A will react with X number of gram equivalents of B to form X number of gram equivalents of product C. 1 gram equivalence of anything will react with 1 gram equivalence of any other thing to form 1 gram equivalence of the product. Means X gram equivalence of A will react with X gram equivalence of B to form X gram equivalence of C. This is one of the very important finding that we have, and this finding we basically use for analyzing the questions in environmental chemistry, especially if they are framed from water quality parameters, right? This is a very important fact that always you should keep a check. A is reacting with B to form C. So if X gram equivalence of A I know, if in the solution X gram equivalents of A are there, then I can write down this X gram equivalence of A I have known, right? This is known to me. This is known to me. And I need to find out the quantity of B and C. I need to find out the quantity of B and C. I know that in the solution X gram equivalence of A is present. And I need to find out the quantity of B and C. So using the previous fact, you can very easily relate and can say that X gram equivalence of A will react with X gram equivalence of B to form X gram equivalence of C. Means if you know the number of gram equivalents of any one reactant, you know the number of gram equivalents of the other reactant, and you also know the number of gram equivalents of the product formed. So X gram equivalence of A, X gram equivalence of A, X gram equivalence of A will react with X gram equivalence of B, X gram equivalence of B to form X gram equivalence of product C. It's a very important fact, very important fact, right? You should always take care of this fact. So I hope this is clear to you. I hope this is clear to you, right? Chalo. Moving on with this. I thought of giving you some idea about this. So, okay, this is the titration that we have. So, we have this, you might have seen this titration, you might have performed this titration in your school. Some of you have even done in your college level. Then in the titration, we have one chemical which is filled in this burette, right? And we have another chemical which is present in this conical flask. So, what you do, you simply open this knob and you add this chemical drop-wise into the conical flask and you continuously stir it, right? So, you note down the initial volume of this chemical which is there in the burette. You note down this initial reading. You note down this initial reading, right? You note down this initial reading. You note down this initial. You note down this initial reading. You note down this initial reading, right? And then after performing the titration, you will get the color change. Then you note down this final reading. Then you note down this final reading. Okay. Then you note down this final reading. Now usually whatever chemical that we fill here in this burette, for this chemical I know the normality of this chemical. For this chemical is first of all known as titrant. This chemical is first of all known as titrant. For titrant, normality is known. Normality of titrant is known. Normality is known. Normality of titrant is known to us, right? I know the normality of titrant, that is N. Then from this burette, I can calculate how much volume of this titrant is used. So volume of the titrant can be calculated using burette. Volume of the titrant can be calculated using burette. Can be calculated by burette. Can be calculated by burette, right? You measure this initial reading, you measure the final reading. The difference of initial and final reading is the volume of this titrant used. And this is VML, right? Normality you know, normality of titrant you know, then volume of titrant you know, you can calculate the number of gram equivalents of titrant used. Now usually this titration is performed to calculate some parameter, some chemical parameter. This titration is performed to calculate some chemical parameter. To calculate some chemical parameter, right? For calculating this chemical parameter, we take use of this normality of titrant and the volume of titrant, because X number of gram equivalents of titrant will react with same X number of gram equivalents of the chemical parameter. X number of gram equivalents of titrant will react with X number of gram equivalents of the parameter, and once the reaction is completed, you will get this color change. I think now your concept of titration is clear. You are adding titrant to find out a chemical parameter, right? You know the normality of the titrant, and from the burette you calculate the volume of the titrant used. But one fact you already know, that X ml of the titrant will react with X gram equivalents of the titrant will react with X gram equivalents of the chemical parameter. And once this reaction is over, you will get the color change. So now you can definitely relate that X gram equivalents of the titrant, X gram equivalents of the titrant, X gram equivalents of the titrant reacts with X gram equivalents of the chemical parameter, reacts with X gram equivalents of the chemical parameter. So in simple words, I can write down number of gram equivalents of titrant, number of gram equivalents of titrant is equal to number of gram equivalents of chemical parameter. Number of gram equivalents of chemical parameter is equal to the number of gram equivalents of the chemical parameter. Now this chemical parameter can be anything. It can be of your choice, any chemical parameter. Basically, why we perform titration? We perform titration to determine the chemical parameter. And titrant is such a chemical which reacts with the chemical parameter. Okay. So number of gram equivalents of titrant is equal to the number of gram equivalents of the chemical parameter. Now how to calculate this number of gram equivalents of titrant? So number of gram equivalents of titrant, number of gram equivalents of titrant, number of gram equivalents of titrant is equal to normality of titrant is equal to normality of titrant, normality of titrant. This will be mentioned in the question, right? You need not to worry about this. Normality of titrant multiplied by volume of titrant used. Volume of titrant used. And this volume of titrant used, you can measure it using the burette. Final initial reading minus final reading, right? Then you have this. Normality will be N. It will be given to you. Usually this normality is unitless. Or sorry, not unitless. It will be number of gram equivalents per liter. Then this volume usually is present in ml. So if you are substituting this volume in ml, you just multiply it with 10 raised power minus 3. And this will become a standard formula to calculate the number of gram equivalents of titrant. So number of gram equivalents of titrant is N into V volume of titrant used in ml multiplied by 10 raised power minus 3. So this will be the number of gram equivalents of titrant. And once you know the number of gram equivalents of titrant, you know the number of gram equivalents of the chemical parameter. Therefore, number of gram equivalents of chemical parameter, number of gram equivalents of chemical parameter is equal to the same, that is N into volume measured in ml multiply by 10 raised power minus 3. Okay. Now from this, you need to calculate the concentration of the chemical parameter. So concentration of chemical parameter will be concentration of chemical parameter will be concentration of chemical parameter this is equal to number of gram equivalents of chemical parameter multiplied by the equivalent weight of chemical parameter. Concentration of chemical parameter is nothing but number of gram equivalents of the chemical parameter multiplied by the equivalent weight of chemical parameter. So concentration of chemical parameter is number of gram equivalents of chemical parameter, that is N into V volume measured in ml multiplied by 10 raised power minus 3. I need to create some space here. Just 1 second. Multiplied by the equivalent weight of chemical parameter. Equivalent weight of chemical parameter. Multiplied by the equivalent weight of chemical parameter, right? So this is how you can calculate the concentration of the chemical parameter. Basically, if we are performing the titration, we are performing the titration to calculate the concentration of the chemical parameter. Okay, and this is how you do it. This you already know. This is the number of gram equivalence of chemical parameter. This is the number of gram equivalence of chemical parameter. Number of gram equivalence of the chemical parameter, right? So this is how we do it. And these are really the basics of chemistry that will actually help you to solve complicated questions of water quality parameters. A student lags in these basics, and that is why he is not actually solving it correctly. So if you have seen this session, please share it with everyone, each and every friend of yours, so that even he or she can get the benefit whatever we have discussed in past 1.5 hours. Okay. I was about to give you some introduction, but if you want to see all these water quality parameters in detail, again you can take up our online courses, you can take up our classroom courses, or even you can opt for the hybrid program, where we discuss all these concepts with pictures, with diagrammatic representation. In detail, we go with the analysis, just like we did for the previous basics of chemistry. So there are very beautiful concepts in environment, there are very interesting concepts in environment, and these concepts can be directly related from the practical life. So I hope you might have enjoyed today's session. You have seen and brushed up a lot of basic concepts that you have already read. But now all these concepts are way properly revised and you actually know how to deal with each and everything properly. So this is all for today. I hope you have enjoyed the session. Please share it with everyone, each and every of your friend. Again, I would like to make few announcements, and those announcements starts from this Telegram group. The link is given in the description box. If you want to have daily quizzes, you can join our Telegram group. If you want to have daily job notification updates, and also if you want to have this lecture PDF and have the YouTube session details, again you can join our Telegram group. The link is given in the description box. One more thing, my dear students, we regularly conduct webinars and seminars for orienting the students, for making them aware about the new things that are coming up in the industry. So again, those links will be there in our Telegram group. So again, you can join our Telegram group for that purpose. We at IMS Gate Academy, we offer you with 4 different types of program where we provide you with 800 hours of live teaching with interaction, with doubt solving. We provide you with theory and exercise book containing 4,000 plus practice questions, well versed in level 1, level 2 and level 3, so that even you can analyze what is your preparation level. We provide you with the GATE question bank containing 34 years of GATE question, in which detailed solution, alternate solution, video solution, key points with chapter overview is present. We provide you with 12 personalized one-to-one mentoring session, and IMS Gate Academy is the only institute providing personal guidance to all our students. We provide you with India's largest test series containing more than 130 plus tests, which includes chapter test, subject test, multiple subject test, advanced subject test, full-length mock test with the video solutions. And we personally take care of our students so that they can outperform everyone in the market. So thank you so much. If you enjoyed the session, thank you so much for listening patiently. I'll be back tomorrow, same time, same place, 3 p.m. at IMS Gate Academy YouTube platform with the another foundation session of environmental engineering. Thank you so much. Have a great day ahead.